Okay, let's go ahead and review how to multiply real numbers. Most of this will be familiar. So let's start with some basic properties. Start with the multiplicative property of 0. If you have any real number, so let A be an element of the real numbers, so any real number, if you take that real number times 0, the product will be 0. Or if you take 0 times the real number, the product is 0. Multiplication is commutative, so you can multiply in any order you'd like. How about if you multiply by the number 1, so the multiplicative property of 1. So if you have any real number, A, and you take that real number times 1, you just get A. So the real number remains unchanged. And if you take 1 times any real number, you get that real number again, A. So for multiplication, we call the number 1 the multiplicative identity, because when you multiply by 1, it does not change the number. It's very similar to addition, where when you add 0 to a number, it doesn't change the number. So 0 is the additive identity, and positive 1 is the multiplicative identity. What if you multiply by negative 1? Well, if you have any real number A, and you take that times negative 1, you just get the opposite of the real number. So multiplying by negative 1 just gives you the opposite of the real number. So for example, let's say A is negative 1. So now you're taking negative 1 times negative 1. So you should just get the opposite, which is positive 1, which is going to be useful when we talk about how to handle negative numbers. All right, so again, these should be familiar, but we'll go back through them, some basic multiplication rules. If you multiply two positive real numbers together, you should get a positive number. So the product of two positive real numbers is positive. So if you take A times B, and if A is positive and B is positive, then the product should be positive. And that shouldn't be too surprising, because if you take A times B, you're just taking the number B and adding it to itself A times. So if B is already positive and you just add another B to it and another B and another B, you just keep moving right down the number line, and it's going to end up positive because you're on the positive side of the number line. What's more interesting is what if you multiply two negative real numbers together? So the product of two negative real numbers is actually positive. And maybe a quick explanation why. So if A is positive and B is positive, then if you throw a negative out front, they're now negative numbers. So a negative real number times a negative real number. I can write those negative signs as negative 1 times A and negative 1 times B. And then since multiplication is commutative, I can write it as negative 1 times negative 1 times A times B. Well, when you take any real number times negative 1, you just get the opposite, which is positive 1. And positive 1 times positive A times positive B, those are all positive, so you'll end up with a positive product. So multiply two negative numbers together, real numbers, you get a positive real number. Well, what if one real number is positive and one real number is negative? So let's say A is positive, B is positive, but it's got a negative out front, making the whole thing negative. So you just have one negative, so that's a negative 1. So you have negative 1 times a positive A times a positive B. Well, A times B is positive, but it's got the negative out front, making the whole thing negative. So a positive real number times a negative real number will end up being a negative real number, a product that's negative. You guys have used that a lot. That's not going to be terribly new, but something you don't think about too often is absolute value. So we'll just add a little bit more to our knowledge of absolute value. Let's have C and D be any real number. So C and D can be positive or negative, doesn't matter, any real number. If you multiply C and D together and take the absolute value, you'll get the same exact thing if you did the absolute value of C separately, the absolute value of D separately, and then multiplied those two answers. So the absolute value of a product is exactly the same as the product of the two absolute values. So that may make sense to you right off the bat, it may not. So I've broken it down into actually four cases to show you that this really is true. Case 1 is C is positive and D is positive. So the absolute value of CD, well, C times D is positive, and the absolute value of a positive number is just itself, C times D. And then the absolute value of C, since it's positive, will end up just being C. The absolute value of D, since it's positive, ends up just being D. So you get CD. You get the same thing in both cases, so that must be true. They must be equal to each other by the transitive property. Well, what if one of the numbers is negative? So let's have C be positive, but then throw a negative out front, making the whole thing negative. Well, the absolute value of a negative number just ends up giving you back the positive of that exact same number. And then the absolute value of negative C will be positive C, and C times D is CD. So you get the same thing in both cases. Case 3 is the same argument, except for the other number D is now negative. But case 4 is what if both C and D are negative? So C is negative and D is negative. Well, we know that a negative 1 times a negative 1 is a positive 1, and you're back to just CD, which we know is CD. And then the absolute value of negative C is C, and the absolute value of negative D is D, so you end up with CD again. So no matter what combination of numbers you use here, that'll always be true. All right, so let's practice with some numerical expressions, and then we'll practice with some algebraic expressions. So let's say we want to take negative 3 times negative 2 times negative 1 times 4 times negative 5. One way to think about it is you can go count the negatives. You've got 1, 2, 3, 4 of them. So that's like having 4 negative 1s. And then we have a 3, 2, 4, and a 5. 3, 2, 4, 5. Well, negative 1 times negative 1 is positive 1. Negative 1 times negative 1 is positive 1. And then we have a 6 and a 20. And 6 times 20 is 120. And anything times 1 is itself, so we just end up with 120. Well, what if there's a 0 in there? We could use our 0 property. 0 times 13 is just 0. And then 0 times negative 15 is 0. And 0 times 24 is 0. Because anytime you multiply a real number by 0, you get 0. So if anywhere in your multiplication there's a 0, it's going to ultimately make the whole product 0. Well, what if we have some variables? Doesn't really change a whole lot. So if I have 2 times negative 3x times negative 5y, I have two negatives. So that's like having two negative 1s, and then a 2, a 3, and a 5. 2, 3, 5, and then the x and the y. Well, negative 1 times negative 1, we know ends up being positive 1. And then we have a 2 and a 3 is 6, a 6 and a 5 is 30, and then the x, y just kind of tag along, not really anything to do with them. On this other one, we have a negative, so let's think of that as a negative 1. And then, so we just have a negative 1 times 2 times p times q, so not really a lot to do there. We just end up with negative 2pq. On the other side of this addition symbol, we have one negative, so there'll be a negative 1, a 3 and a 2, which gives us 6, but it's negative, and then a p and a q just tagging along. But in this case, we now can add these together because they're like terms. So p to the first, q to the first, p to the first, q to the first, they're like terms. So a negative 2 of these plus negative 6 of them is negative 8 of those.